Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this inequality to solve. We have x minus 2 all to the power 301 over x minus 1 all to the power 703 times x plus 3 all to the power 401. Okay. So analyzing an inequality is studying the sign of the function, where the sign is positive and where the function is negative. So for this particular case, we check that the exponent of our individual functions, because this is a function also x minus 1, we realize that the exponent is odd number. For the numerator is odd, for the denominator they are also odd. So we can reduce this number into the lowest odd number we can. So if we check in the real line, the oldest number that we have is 1. So since inequality is studying the sign of the function, this inequality, it's not wrong if it's written in this particular case like this. Okay, because this number is odd and 1 is odd. 1 is odd, this number is odd. This number is odd, 1 is odd. So inequality is not like equation whereby you're going to be losing solutions there. No, this is equivalent to this. So that means the solution of this inequality is the same as this one. So we can reduce this into 1 because it's both odd. Okay, perfect. Now, so having that, now we have division of two expression. It's like a fractional number. It is a fractional number. So when does the division of a fractional number will be greater or equal than 0? Okay, first of all, we know that this division can be only possible if our denominator is never 0. Because if you take, even if you take your calculator, do any number, divide by 0, will say error. So doesn't exist. That's why it's infinity. So what we do now, we can state that our denominator can never be equal to 0. They can never be equal to 0. Okay, so x will be different than 1 and x has to be different than minus 3. Okay, because if x is 1, then this will be 0. So our denominator can never be 0. So it cannot also, so that's why our denominator cannot be 1 and cannot be negative 3. But what about our numerator? Can it be 0? Yes, it can. Our numerator can be 0. We can find the roots of our numerator, so which is x equal to 2. So our numerator can be 0, but our denominator can't be 0. So after analyzing like this, then we can make our real line here to analyze the solution. So we can organize in terms of greater and lower. So minus 3 is of course the lowest one, 1 and 2. So how do we go about it? So we can take a number from this interval from negative infinity to minus 3 and try substitute there to verify if it's gonna satisfy the condition greater or equal than 0. We can take minus 4 here. If we take minus 4 and we put it here, we're going to realize that here will be negative, here will be negative. Negative times negative is positive. Since here will be negative, negative divided by positive, it's negative. So this interval, it's negative. From minus 3 to 1, we can take 0 here. We can take 0. If we take 0, substituting here, so here will be 3, here will be negative, this multiplication will be negative, this is negative, negative over negative is positive, so positive is greater or equal than 0. So here will be positive in this interval. From 1 to 2, we can take 1, 5. 1, 5 here is positive, here is positive, here is negative. So negative over positive is negative. So for 1, 5, here is negative. So from 2 to plus infinity, we can take 3 here. So here will be 2, positive, positive, here will be 0. Satisfies, 0 is greater or equal than 0. So I can say here, positive. So since our sign is greater or equal than 0, in other words, we need positive numbers. So we're going to take the positive where there is positive sign. So where there is positive sign. So that means our solution is going to be from minus 3 to 1. But the thing is, x can't be 1, so the interval has to be open. When we put curved interval, that means it's the same as open. Some people prefer putting like this, which is exactly the same. So if we check, this is open, but this part does not satisfy, so we put union and from 2 to plus infinity. From 2 to plus infinity. Infinity is always open, but 2, according to our sign, is greater or equal. Since 2 is the root of the numerator, so 2 can belong. If it was just greater, then 2 will have been open, because 0 will never be greater than 0. But since there is greater or equal, then 2 can belong to the interval. Okay, perfect. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.